route reflector in BGP, route reflector in Cisco, BGP route reflector in Juniper. The end result is same, but they don't work in the same manner. Now, first of all, why do we need route reflector? The routes that is coming from eBGP, which is learned in this eBGP, is distributed. It is given to iBGP. To avoid loop and duplication, there is a iBGP split horizon working there, which prevents Olive 5 further distributing that. So this particular network reaches up to Olive 5, but the network don't go to PE2. Similarly, this network goes from here to here. Because it is eBGP, it will go, no problem. From here to here to Olive 5 also it goes, but further it don't go. Further it is not going. So as a result, what happens? Site 1 network is not learned in Site 2. So people from Site 1 and Site 2 can't reach. The very first solution that we learned in BGP class is full mesh. Full mesh will solve the problem. What is full mesh? Not only forming neighbor with these two, you also form neighbor with this one, so that updates can be directly given. It is TCP based protocol, so updates can be delivered to the neighbor which is far away. Similarly, forming neighbor with this and as well as this. So full mesh is one solution, but it is not a right solution. The reason is CPU will be used again and again. When you have many neighbors, then many sessions need to be maintained. Many times the updates need to be replicated and sent. So CPU is going to go high. So it is not recommended to have full mesh. Then what is recommended? If it is a large network, go for MPLS layer 3 VPN between PE1 and PE2, so that you can have a BGP core, free core, BGP free core. No BGP is needed when you form tunnel. That's called BGP free core network. You form a tunnel, which we learned in our MPLS class. But for this topology, there is one simple solution available. If you don't want to go with the solution full mesh, there is a solution available. What is it? Route reflector. So the route comes up to here, the yellow route, and then the blue route from the right side. It comes up to here. But from here it is not getting further distributed to the downstream. Olive 5 is not ready to give to PE2 or PE1. In Cisco, what we do, we go to this router and say, hey, you got a client. RR client. You got a client. Route reflector client. Give him the route. You are giving permission. You are saying that usually you don't give, I know that, but I want you to give. I'm a owner of this router telling you, you give. Means you are overriding the default after knowing that duplication loop won't occur. In this, duplication or loop won't occur. So you know that duplication will not occur if it goes from OLE5 to PE2. So you grant permission to give. The command is simple: neighbor 2.2.2.2 route reflector client. That's the command we used to give. So now what happens? The yellow update will go here. And it will also go here now. What about the blue line? OLE5 is not configured with a client 1111. You did not configure. You see, we have only said 2222 as a client. 111 is not configured as a client by us, though it will go, because it becomes a passive client. I repeat, PE1's yellow update is reflected to PE2 on configuring this line. In return, Nandri Kadanaga, whatever PE2 gave, OLE will give to PE1. Even though you didn't configure PE1 as a client, because I gave the route given by PE1 to PE2, in return, I will give whatever PE2 gives to PE1. So, blue route comes here and it will also go to eBGP. So, this is one solution. This is how Cisco device works. If you say both the side client, router reflector client 1.1.1.1, that is okay. You can say, but in this scenario it is not needed. The reason is Cisco has got something called non-client. Non-client, it can route reflector server. This is what server, because if you call the others as client, then it is server, because the server has given this guy's route to the client. It will also give the client route to this guy, which means passively this becomes a client. In another word, it's a non-client. This is configured client, but this is also a client, though it is not configured. Non-client. So far what we have seen, route reflector solves the problem. It reflects the route. Now coming to the Cisco, Juniper story. In Juniper, we don't say this as a client or this as a client to this server. We don't say like that. We say, hello server, you got already a neighbor, right? You got neighbor 1111. You got neighbor 2222. To them, you be a cluster. You be a leader. Whatever they don't know, you give them. That is what called as cluster. You made this as a cluster leader for this cluster, for this group. Like a designated router in OSPF. You say, as soon as you say cluster ID 5.5.5.5, immediately this guy will take the position. Aha, thank you for making me a leader. Now I'll show that I'm the best king for these people. I will give them all that they don't have. So this guy do not have this route, so it will give. This guy do not have this route, so the cluster leader will give to the members. That's the approach in Juniper. In Juniper, you don't configure client. Instead, you say the address that is used by the others as a neighbor. Others identify this Oli 5 as 5.5.5.5. Mention that and say you are a cluster member. You are the ID. For this group, you are the leader. This is one cluster. Means these two are the neighbors, right? For this router. So you say for this cluster, the cluster ID is this. Then this way, what? Me? Okay. Then I'll take rule. I'll take control. Don't worry. So it started advertising. Whatever learned from this side, it gives this side. Whatever it learned from this side, it starts giving this side. This is how Juniper works. I'll quickly show you this quickly. I'll take you to Oli 5 and show you that configuration. I already configured, so I can straight away take you there. Root Cisco 123. I keep in Juniper Cisco. Hey, come on. What did I do? I made a mistake. Control C. Okay, so CLI config. This is under BGP, so I'll say edit protocol BGP show. You see here, I have made 1.1.1.1 and 2.2.2.2 as a neighbor, and I said cluster. And this is how IBGP is configured. Local AS and peer AS is same autonomous system number. I hope you understand this because you're from Cisco, you know the configuration. Here we, like a peer group, we configure, and then we say in this group these two are the members, which is PE1 and PE2. I'm showing on Oli 5. Okay, this is on Oli 5. And then they both belong to this AS, and then the local address from, see, this is the equivalent command to update source loopback 0 in Cisco. So we say local address is 5.5.5.5, and then we say cluster 555. This makes Oli 5 to reflect the PE1 route to PE2 and PE2 route to PE1. So whatever it learned from this neighbor, it will give to this guy. Whatever it learned from this guy, it will give to this guy, which is not default behavior. Default behavior is route learned from one IBGP should not be given to another IBGP. Okay, as a result, the routes are reflected. Now if I take you to PE2, you can see them. You can see those two routes coming from site 1 and site 2. So route. Okay, now what I want to show, okay, here I want to show you BGP output. Show route protocol BGP. You can see that this is learned from the cluster. See, this is cluster ID. From the cluster 5.5.5.5. This is learned from EBGP. See 22.0.0.5. I'm showing the output on PE2. PE2 is directly connected to this guy. It is learned through EBGP. The autonomous system number from where it is coming is 30. And the administrative distance or the preference value in Cisco we call administrative distance. Here we call preference. It is same for both EBGP and IBGP. In Cisco we have 20 and 200. Yep. So you can see that a route has come because of the reflection. As a result, if you go to site 2 and ping site 1, you will be able to reach. root Cisco 123. This is customer 1 site 2 on the right, and here we say CLI, and then show route itself will show you the route. See, via BGP we have learned the route of the remote site. This is the local site Lubeck. This is the remote site. So if I ping from here this address with a source, this address, local address, I should be able to reach, if everything is fine, I'm able to ping. This is a known topology for you, so I did not go much deeper. I simply want to show you one more time the configuration, like BGP configuration. Let me show you here. Config. I just want to show you only. Okay, I'll show you all the configurations in this device. So, what is this means? I have enabled authentication, and then what does this means? This is the IP address on the Ethernet interface, and it belongs to IPv4 family. And this is the IP address on the loopback interface that also belong to IP family, IPv4. And look at this eBGP configuration. This is the peer group name, eBGP, so external, and then local address. We are not using loopback address in eBGP. Local address is 22002, and then the peer is in 20, different autonomous system. Local autonomous system is 30, and this is the PE2 address, P2's address. And then in Juniper, to advertise a network, it is not that easy like Cisco. In Cisco, what do you do to advertise a network? You type network command. But here you need to write a policy. See, this is that policy. I have written a policy saying this particular route, this is our loopback 172.16.02. This particular thing, if it matches on this routing table of the router, then you accept it in BGP algorithm and export them to the neighbor. See, I'm calling the policy. So that makes the distribution to eBGP, and iBGP has got no problem. It will give to these guys, and then it has come here. Now let me quickly show you ISIS configuration. Edit, exit, edit protocol ISIS, show. So this is the ISIS configuration. ISIS is running on these 3 interface. But this is not the whole configuration of ISIS. Let me show you here by typing show. This will show you on the loopback interface only. We will give N selector. You remember these things? We used to put under router ISIS. But in Juniper, it needs to be done under the loopback interface. All right, and then the reason why we joined the family ISO is ISIS is originally designed for CLNS, but what ISIS we want is IP version of ISIS. That's why we joined to a family of ISO. ISO only designed iOS. What am I saying? ISO only designed the 7 layers OSI. So that's a standard defining thing. So we are saying IP standard of ISIS we want, so we join that family. In fact, all the interface that runs ISIS should join that family. And then these are the interfaces running ISIS. We also have iBGP. Because it's router 5, it's a middle router. There is no eBGP configuration. You see only iBGP configuration. I have already showed you this. Alright, that makes this topology function. Do you have any questions?